Greetings to everyone. My name is Harshdev Singh and I'm delighted to present our research title Leveraging Machine Learning to Uncover the Relationship between Diabetes and Alzheimer's Disease Progression at the 8th International Workshop on Computer Modeling and Intelligent System. This research has been conducted in collaboration with Mannat Rajput and Alankrita Agarwal from Chandigarh University EIT CSC. Diabetes-associated cognitive disease is growing concern as diabetes have been strongly linked to cognitive decline, including Alzheimer's disease. Our objective is to develop a predictive model for early detection of this disease using reinforcement learning. Our model is designed to identify patterns in patient data, predict cognitive decline, and refine accuracy over time using this reinforcement signals. By enabling early intervention, this model has the potential to support mental health professionals in identifying high-risk individuals. Cognitive decline in diabetic patients is often overlooked, leading to delayed diagnosis and limited treatment options. Early detection is crucial for timely intervention and personalized care. However, existing models for predicting cognitive impairment rely heavily on centralized medical data, leading to privacy concerns and adaptability issues. Additionally, traditional diagnostic methods struggle with integrating lifestyle and clinical factors to make accurate predictions. To address these challenges, we propose an AI-driven approach that utilizes reinforcement learning to enhance adaptability and accuracy. Our model is designed to analyze patient biomarkers, medical history, and cognitive health indicators, refining its predictions through continuous learning. Despite advancement in healthcare, several challenges remain in detecting diabetes-associated cognitive disease. First, lack of early detection methods for diabetes-related cognitive decline. Second, difficulty in identifying key biomarkers from diverse patient data. Third, challenges in integrating clinical and lifestyle factors into predictive model. To overcome these issues, we have developed an ML-based predictive model using decision trees, random forest, and neural networks for high-risk patient identification and early intervention strategies. Our research builds upon existing studies that establish the link between diabetes and cognitive impairment. Prior works have demonstrated that reinforcement learning improves predictive accuracy in healthcare. Patient health records reveal hidden patterns in disease progression. Privacy concerns remain a key challenge in medical AI, and adaptive AI models can enhance personalized cognitive care. Now, our model follows a structured machine learning pipeline. First, data preprocessing, cleaning, normalization, and feature extraction from patient health records. Second, feature selection, identifying key predicators such as age, BMI, blood pressure, and cognitive decline indicators. Third, model training. Random forest handles structured clinical data and identifies important features. Neural networks captures complex relationship between medical and lifestyle factors. Fourth, model optimization, fine-tune using grid search and random search. Fifth, evaluation and validation, measured through AUC ROC, accuracy, precision, and recall. Our experiments results demonstrate that neural networks and random forest model outperform traditional methods in detecting cognitive decline among diabetic patients. First, performance metrics confirm improved accuracy, recall, and precision and early detection. And then, validation laws and classification reports show a stable model training and robust predictive performance. Our study confirms that reinforcement learning can significantly improve early detection of diabetes-associated cognitive disease. This work contributes to enhanced cognitive healthcare solutions and timely intervention strategies. For future work, we plan to expand the dataset, integrate wearable health sensors data, enhance explainable AI, and then deploy model in cloud-based healthcare system. In conclusion, our work represents a significant step forward in AI-driven healthcare. We believe that with further refinements, this model can contribute to personalized cognitive care and improve healthcare decision making. Thank you for your time, and I look forward for any questions and discussions.